and it's very similar to what you'd have to do. So you'd have to load the package. We use a package called RS Logic, which is part of a factory called package. We do a lot more with it. What we do on that time. But this is a PLC program. You see it's very similar, except for not using dots. So we don't like that. Dot. That's the deal. So what you do is, let's see if we can see the addresses. Is you have what we call input ports on the PLC and output ports. And then what you do on the input ports is this is where you connect your sensors. You actually have screw terminals on the bus. We might have one around here. We're supposed to have one in here. Oh yeah, there it is. This is 1100 PLC and it has a fixed PLC. Relay and relay output. But we could use the AC. Also, this is 11,000. I don't have my camera with it. Pass it around. And we'll open up these little covers here so you can see the inputs and you can see the outputs. What you do is you supply, you jump down what voltage you want to use on your output. So it says I could use either DC or AC, and I hook my DC or AC to the indicated terminals. Or you don't even have to do the same thing to each one of them. If you notice, each output has got its own terminal where you bring the voltage in. So I mean, some of them you might be running a DC circuit, and some of them you might be running an AC circuit. And then up here, here's our inputs. We have 8 inputs up here. We've got 9 inputs. And so you have two screws for each input. That's not true. You make what we call a common, and then all you do is run that common out to your switches. But common is a relative term. What we can do on the PLC is we can hook our inputs on what we call syncing or sourcing. Sourcing means you would connect the power to the switch, and then when you hit your button, it would put power on the input, put a voltage on it. Syncing means you connect the voltage, you connect the switch to ground, and you connect the power to the input. So here, if you press the button, it provides the ground. If you don't, it applies power. That makes sense. But here's our timers right here. So what we do to program it is we just come up here. So we come up and we get a blank screen. When you start a program, you have to specify what processor you got, what modules you got, and all of a sudden these two. But this is where you got. This is what you got. So you got an L1 and an L2. PLCs do not show line numbers; they show rung numbers because they have no idea how many lines you're going to put in. And then you come up here and, if I can remember, you got it on program. And then you select what you want to put in there. So if you want to put a normally closed contact, you drag it and put it right there. And then it's asking you, okay, where's this contact coming from? So if you look at the front of the panel when we pass it around, you see it's got IO 0, 1, 0, 2. Well, what we call that is what we call an address. And we would come up and double click on it, and then we'd say this is going to be IO. How does it go? Oh, you remember? You had it IO. No, it's not semicolon. It's colon, right? Okay. Yeah, 0, and then we'd say, well, it depends on. So what you do is you select a module, and a fixed PLC uses what we call the module is always 0. That makes sense. So these came up to what we call. We'd have to go down to the motor controls lab, and the computer lab, the PLCs in the back. We can buy PLCs in 3 different configurations. We can buy them as what we call rack mount PLCs. And what you do is you buy a CPU and a power supply, and then your input and output modules you plug into the rack. And that way you specify what type of modules you want, whether you want a DC module or an AC module, or if you want a relay module. And you can get output modules, input modules, you can get A to D modules, analog to digital modules, you get digital analog modules that you plug into this rack. So it's kind of like the old days on computers when we call them expansion slots. So we go out and we buy a motherboard. So originally when the PC came out, it had a microprocessor on it, and it had all this other stuff, and it had 8 expansion slots out there. And what you did is you went out and you bought what cards you wanted to plug into that expansion slot. You'd have to plug the video card in there. The video wasn't integrated. Video, sound cards, and all that kind of stuff. If you didn't want sound, you just didn't want. You didn't buy a sound card, and all you got was the beeps that came out of the computer. Well, that's the way a rack-mounted PLC is. So if you buy what modules you want on your PLC. Then we have fixed PLCs, which is like the one I passed around. A fixed PLC, you get what you get. So I can't, where's it at? How many inputs do we have on that? How many outputs do we have? We have 9. I know we have 9 inputs. I don't know how many outputs. 5 outputs and 9 inputs. Well, that's what you got. Then we have what we call hybrid PLCs, which looks a lot like a fixed PLC, but the side snaps off of it. And you snap other modules into the side. It's not rack mounted, but it's side mounted. And these mount on rails that we call DIN rails. I don't know if you ever seen a DIN rail, but it's got flat and it's got 2 edges on it that, I'll have to show it. And then you got a little spring load thing on your PLC and your modules that you come in and you so if you looked at it from the side, it would look like a T. It would come out like this, and then it would drop down, and then it would have a T on it. Of course, if you looked at it on the top, it would look like this. And of course, you'd have the screws that's mounted in there. And the way the PLC mounts is it's got a lip on it that goes into here. And then up here, this is a spring-loaded unit. So what you do is you pull it up and push it onto the DIN rail, let it go, and it locks it in. You can get these DIN rails as long as you want to. So it's not a rack mount PLC, but it's the next best thing. Because you can buy it fixed, and you go on, you say, and they're cheaper. These fixed PLCs are cheaper than the rack mount. I mean, they're a lot cheaper. So these are fixed PLCs. The ones we've been buying lately are hybrid PLCs, which is pretty neat. What you have to do is you assign, if you look at the addresses on the thing, where's it at? The PLC? I need it back up here. I'm sorry. So we would say this would be right. Normally, if you got a fixed PLC, then the address is 0. So it's a 0 slash, so that would be the rack number, and it would say 1. And I didn't like that. That wasn't right. Oh, I'm sorry. It's N, not IO, colon. So it's N, and then we'd say 0 slash 1. So what that says is that whatever I connect to rack to module 0, and it would be the first input port only. And that's the way we address those things. So that means, okay, I would come over here and I'd add a push button or something on those actual screws out there. So what you got to say, some of y'all are having problems with this because some people's had PLCs and it says hook 3 push buttons in operation, and you use this symbol right here. This is not the symbol for a push button. This is a symbol for a contact. Now, normally when we say a contact, we're talking about a relay contact. But on PLCs, it's a contact. Now, when I draw the drawing for my connection, we would use the symbols that we learn in motor controls. Y'all understand that? So if I hooked a push button up to input 1, then when I drew that hook up, I wouldn't draw the symbol for a contact. I would draw the symbol for a what? Push button that controls this contact. And of course, you have the ability to give comments. And then, of course, if I want to relay, these are relays. This is a latching relay. So we have two coils. Remember, you have two coils on a latching relay. You have what? Latch and unlatch. So those will actually be two separate coils. But this would be a contact. Notice when I put it in there. And over here, I'd have to say O. What's O? Out. Then I'd put a colon and maybe rack 0/1. And it didn't like that. Huh? Oh, I'm sorry. Yeah. So you can't have, thank you, or one. We can't have the same devices on in the same module. Does that make sense? So this is probably one. We'll try that and see if it works. Colon 1/, and by the way, the contacts has to go from 0. And then we enter that and see it took it okay. So and then of course what you would do if you wanted to come up is you could come up here and, if I can remember how to do that, edit symbol, and you can give it a name. And now I could use, anytime I use the IO address in 0.1, it'll automatically call it what? Rich. And this would be kind of like we label our contacts. And this is something you need to get used to doing because the label will give you an idea of what that does. And then when we got it going, we would come over here and, well, we can run it. So what we'd have to do now on our PLC, right now we got it what? Offline. So what we do is we would go online. So you can write programs. You could write your program at home. You're just offline, write your program, and then you would come up and once you get it there, you'd have to download it to the PLC, and then you'd have to switch the PLC to run. So this is simulating the PLC. A lot of your the old PLCs used to have a switch on it. It was a key switch on it, and you had to switch it from program to run. And everybody would forget to do that. Most of your hybrid PLCs, you do it through the application. So you're connected. If you want to switch it to run, you literally have to connect the computer up to it, and then you switch it to run, and then you can disconnect it if you want.
That measure inheritance.
What's that?
Beside run and step and program.
No, it's measuring, I can't remember exactly what, it's measuring hex. So what it is that this is a computer, and we have these output ports and input ports. And what we'll do is if we have a 16-bit input port, then it would assign 16 bits of a 16-bit address to what? And it would come up and show you, like, if we had, 1, 0, and 1 on, and they were both true, it would come up here and show you 3. And so you can monitor the registers. So you can monitor the input registers, the output registers. I can't remember where to get to it. I just had it up a while ago. But we'll go ahead and switch it and run. And I don't see it working. It's been a long time. I got to teach the advanced PLC class. So I did use input. I use this input. Let's see, what am I doing? Let's see what I'm doing. Huh? Yeah, so I'm turning on this input, and then what it should turn on this output right here. We have an LED hooked up there. Huh?
Your input on the left right there, switches are starting to move.
And your input on the right is labeled. Well, the thing on the right is labeled.
Yeah, change your output to.
Oh, okay. I see. Thank you. I understand now. It don't have a module 0. Real easy to edit though. So we use 1/0. Okay. And then we have to do what again to it? Oh yeah, I'm still in program, I'm okay. So the output is on module 2/0. So what we would do is this has been wired up out here. Then I have to download it again every time you make changes. Odds are if this was the real PLC and it didn't have the module in there, you'd probably get some type of error. And so what it does is it says, okay, I received an input from this. And then I got an output where there. I don't know why the other didn't come out with something like this. But we do have a module here. We have one, two, out 2, into 3. Okay. So this one starts at 1. Now we have the ability to put binary into it. So literally, if you wanted to put a 4-bit binary number in it, it would eat up 4 input ports. But this is PLCs. And like I said, if you wanted to play around with it, this is for the, this simulates the RS Logic software. And they call it Logic Pro. And you can download it for free. You can use it for 30 days. If you don't use it for 30 days, what you can do is just delete it, download it again, install it, reinstall it anytime you want to. But the license on it is, I can't remember, it's almost nothing. I think it's less than $20. It's like $15. And that's the license. And then you don't have to do what every 30 days. You have to delete it. For the $15, so they give you 5 years free of it. So if they ever need to upgrade it after that, you can keep using it, but if you wanted to get a new version, you would have to relicense it again. Man, you can do a lot of stuff with this. It's got all these really neat. It's got a thing in there that helps you. You can. Oops, we can't see. You can actually show the simulation too. I have to figure out how to do that. This is actually a garage door opening program, which is really neat. I mean, they say, you know, if somebody walks into the door, and it's got all these sensors, which is pretty neat. So they give you all these scenarios that you can come in and do. Like make a light flash when it's in motion, make a light come on solid when it's down, when it's closed, which is pretty neat. And I'll figure it out. Show you that later. But this is called what? And it's for the Rockwell or the Allen Bradley PLCs, and which is really neat. So if you take PLCs, this is what you learn about. But and people will ask me which one's easier to take PLC first and motor controls, or take motor controls and then PLCs. And I tell them it's whichever one you take first, it makes the other class easy. So you'll learn about ladder logic and all that kind of stuff. Now in advanced PLCs, all they do is get up through counters. In the advanced PLC class, that's where we do all the compare operations, all the math. This is a computer. What a PLC can do that a Watt can't do, that relays can't do, is relays can't do math. They can do logic. They can do ands, ors, nots, nors, and nands, right? And they can do exclusives too, but we didn't look at how to wire those up. Exclusive ors and exclusive nors. But they can't add, they can't subtract, they can't multiply, they can't compare, they can't do shifts, they can't do all this other kind of stuff that a computer can do real easy. So in advanced PLCs, what we teach is all that stuff. How to do math, you know, so you can add this and that together, you can subtract this and that. So let's say you wanted to keep up with your rejects and how many you made, how many you ran today, how many rejects you had, what was your total run. Normally we used to have to do that with computers, but now we do it with a Watt. We can do it with PLC because it is a computer. we can check things, say, okay, if the box has 12 in it and shift it this way, well, that would be a compare, right? That would be, you know, we got compares, we got math, we got logic, and that's what we teach if you take the advanced field class. So we get into the high level programming of these things, which is pretty neat. But what we do when we have a timer is, oops, I didn't want to do that. Is notice what you have is you have different places you can go. So here's our timers. So we got we can put a what in there? T on, what do you think that's on? No, that's not time, that's an off, that's a on delay timer. Then we have a what? An off delay timer. And then we have an RTO, okay? That's a retention count timer. And then we have our, we'd have to simulate the other one. Then we have a counter, CTU, what would that be? Count up, CTD would be what? And then REF. This is what you would use to reset your counters, right? Does that make sense? And I think I had a timer in that other lab I wanted to show you. Counter timer activity 3. In fact, this is one of the ones they do in PLCs. So T on, what would that be? Okay, we have timers that, this is timer number 4, so there's the address, right? Then it's got, we're setting the multiplier to what? 0.1. Then we're going to preset it to 50. So this is going to be a 5-second time delay. And what this does when it's running, it shows you the accumulated count. And then all of these are on delay time. But what you do is kind of like our programmable timer, where you come in and set a what? You set a multiplier. Then you do what? So this is the same thing. Which is pretty neat. The only problem with, if I remember the Logic Pro, is that it don't let you change the multiplier. It's always 0.1. But if you got on a regular PLC, then it would be whatever that PLC offers. So it depends on which one of these PLCs you're on what the operating system actually offers you as far as your high level. I hadn't reinstalled. The RS Logic we have. I think we have 20 license on it, and it's renewable every year. It costs us like $4,000 to renew those licenses every year, which is good for education. If you was in industry, you'd be paying after boo-boo. So I can't show you. I was going to show you the program we got in here. Maybe I'll try to do that next class. We got a program in here that runs a motor reverse automatically back and forth. It's really neat. Does it with one timer because it's using all the high level language commands that we got. But I can't show you the program because I haven't installed my license this year. So if I tried to run the RS Logic software, it would say, we can see if it'll load up. I don't remember why. I usually don't install it until I